Circle Christian School supplemental math videos. Intro to functions and their relationships. Many everyday phenomena includes two quantities that are related to each other by some rule of correspondence. The mathematical term for this correspondence is a relationship. These are some basic parent functions. Remember, look at what's happening to the x or the y to determine the basic shape. From there, the h and the k is going to tell you where it hangs out at. These are the basic definitions of what happens with a function. Between a definition, terms, a little bit of function notation, remember that the bracket means that it is a closed part of the notation, and a parenthesis is the open part of a notation. You have the evaluation and a wise tip on piecewise functions. Here's the key. Y equals f of x. Difference quotient. It is the rate of change of a curve in a coordinate plane. Now what you have to do is imagine a curve happening inside of a coordinate plane. So we're going to draw a coordinate plane here. And I'm going to use the example of a car going around a curve in a coordinate plane. So to represent that, here's our curve. And of course, here's our cute little car. And my favorite one, of course, is a Volkswagen Beetle. The old Volkswagen Beetle. And it's going around the curve here. Now, there are two things that basically happen as it's going around the curve. That it is either traveling some sort of distance or some sort of speed. So you have distance or speed, which we're going to call rate. And, rate of speed. And then it's in accordance to what's kind of happening with time. So we have, your input, and then we have some sort of output happening. Well, the rate of change with this that is so important with a difference quotient is we want to find out what the relationship is in such a way that it defines the curve. Now you can do that by making a tangent line. That's a line that hits at one place here. Or you can actually define it by defining two different points on the curve and making a secant line. So you have to kind of go back to a little bit of your geometry inside here. Now remembering that the difference quotient in a coordinate plane was being defined by a slope and giving us a rate of change in such a way that as we have this curve in the coordinate plane, I'm just going to make us a cute little parabola here, and 2 points and the line going on inside here, is just like any type of slope or rate of change. It's the difference of the y's over the difference of the x's. This point right here is going to be x and then the y, which we're going to describe as f of x. And this point here is going to end up being the difference, the change that has happened as it's traveled. So calling the difference or the distance of the x's as h is now going to give us an x plus the h and the f of x plus the h. So therefore the difference here is going to leave us with the difference of the y's, which is f of x plus the h minus the f of x over the change of the x's, which is going to be x plus h minus the x, And noticing that these cancel out, it's going to give you the h, your basic difference quotient. Here's a twist on the difference quotient from the one that we did in class that is in the lesson forward. Evaluate f of x when it equals x squared minus x plus 1, when f of 2 plus h minus f of 2. Now this is a little bit different because you have to be what they call intuitive. Not one of my better habits. It took me a little bit actually to work this one out. But realizing that the 2 here is basically what x is. So what we have to do to find out what f of x is, that is the y here, is we're actually going to have to replace the 2 into the original equation first. And with careful evaluating, you would find that it is 4 minus 2 is 2 plus 1, so y equals 3 equals the f of x. All right, now replacing it back into the problem here and finding that the f of 2 equals a 3, we can now evaluate the problem as it is. So replacing the x squared here and then the x, and of course the plus 1. What you have to remember is, although they don't show it here, really try to use those brackets to separate the two parts of the problem. Now you can replace it by doing the binomial squared and then the binomial, and this is the guy that was kind of the hidden guy inside the problem there. Remembering that you're going to factor out the h's here, and your final result will be x plus 3. Okay, hope that's a help. Thanks for asking that great question of why the difference quotient, the rate of change of a curve in a coordinate plane.